Hello class, today what we're going to talk about is solving equations with rational exponents. So what this is equations like 2x cubed equals 54, or x minus 3 to the 2/5 equals 75, things like that. Alright, so let's just jump on in here. So we need to find the real solutions of these two equations. So let's take A first. We have 4x to the 5th equals 128. So step one is, as always, write the problem down. Now, just like we have always done, our goal here is to get the variable by itself. So we need to get this x by itself. So the 4, the 5, those have to go away. First thing we're going to get rid of is that 4. So to get rid of this 4, well, this is 4 times x to the 5th, so we're just going to divide by 4, same thing we've done for years, right? So we divide both sides by 4, we get x to the 5th equals 32. Now we've got to get rid of this power of 5, right? Well, just like with x squared, we're going to undo raising it to the power of 2 by square rooting it. Here, instead of square rooting, we're going to take it to the 5th root. Right? So we're going to take the 5th root of both sides. So the 5th root there is x, and the 5th root of 32 is the 5th. So we have the 5th root of 32. So we need something that we can multiply by itself 5 times and get 32. And so that would be 2. So x equals 2. And there it is. Now, since our index right here, this 5, is an odd number, we're only going to have one solution. All right, so that makes it nice. One solution, x equals 2. Now for equation B. So here we have x minus 3 in parentheses, all raised to the 4th power, and this equals 21. Well, since that 4 is outside the parentheses, we've got to take care of that first. All right? So just like we did up here to get rid of the 5, we're going to get rid of this 4. We're going to take the 4th root of both sides. So that gives us x minus 3 equals the 4th root of 21. Now remember, since this index, our 4, is an even number, we're going to have two solutions. Just like anything you take the square root of always has two square roots, positive or negative. If we have something to the 4th root, we're going to have 2 4th roots, positive and negative. We have 2 6th roots, positive and negative. 2 10th roots, positive and negative, right? And so we have the plus and minus 4th root of 21. Now, 21 does not have a nice, pretty 4th root. And so we're just going to leave it like this for now. We'll deal with that and stuff later. But for right now, we're just going to leave it like that and get rid of this 3. Because we've got to get x by itself. So we're going to get rid of the minus 3 by adding 3 to both sides. So we have x equals 3 plus or minus the 4th root of 21. Now, since this is two separate answers, we're going to write it as two separate answers. So we have x equals 3 plus the 4th root of 21, or x equals 3 minus the 4th root of 21. That's the plus minus there. And now what we're going to do is we're going to take this, stick this in our calculator, and get some actual numbers for this. And so we have x is approximately 5.14, or approximately 0.86. All right. So remember, anytime you have an even exponent here, or if you have an even index here, you can end up with two different answers. All right? So let's take a look at this. Here we have a real-world situation with this stuff. So a hospital purchases an ultrasound machine for $50,000. Expects the machine's useful life to be 10 years, at which time it will have depreciated down to $8,000. The hospital uses declining balances method for depreciation, which means that it's going to go down by a percentage every year, so it's a different dollar amount, but it's the same percentage. Okay. And so they have this formula right here to figure out what that percentage rate is going to be. Okay. So in this formula, R is the rate of depreciation. What percent is it going to drop each year? N is the useful life of the item. How long is it going to last? S is the salvage value, which means how much is this going to be worth when we finally get rid of it? And C, how much does it cost me originally to purchase it? So what we need to do is first figure out what numbers we can plug in for S, C, and N so we can figure out what R is. Well, looking up here, we see the useful life, N, is 10. So we're going to plug that in for 10. We have the salvage values right there. That's what it's going to depreciate down to. That's what it's going to be worth at the very end of this before we get rid of it. And then we have the original cost of 50,000. So we're just going to take those, plug those in, and we have this 1 minus 88,000 divided by 50,000 raised to the 1/10 power. And we can simplify our fraction there, and then we just stick this in the calculator. And we get approximately 0.167. But since we want this as a percentage rate that it's going to be dropping, we're going to change that to 16.7%. Right? So that's not too bad. Alright, let's do some problems on your own here. So here are here's some problems. 17, I want you to go back to that problem with the ultrasound machine. And so you might need to back it up a little bit to get that right there. Get that equation and that other information. So pause the video, work out these 5 problems, and then come back and we'll see how you did. Alright, so you're back. Let's see. Hopefully you got these as your answers. If you did, great. You did it right. And you learned something. And you're done. If not, we need to go over this to figure out what you did wrong. Alright, so let's take a look at number 13 for those of you who are still here. And we have 8x cubed equals 64. So first thing we do is we divide by 8, which gives us x cubed equals 8. Then we take the cube root of both sides, and x equals 2. Since this is an odd exponent, there is only the one solution, just x equals 2. All right, look over at 14. We again see we have an odd exponent, so there's only one solution. So on this one, what we need to get rid of first is that 1/2. So we divide both sides by 1/2, which is the same as multiplying both sides by 2. So we end up with x to the 5th equals 1024. We're going to take that, and we need to get rid of this to the 5th power. So we take the 5th root of both sides, and x equals 4. Again, only one solution. And on 15, we see, oh no, we've got an even exponent, which means we are going to have 2 solutions. So here they are. All right, first we've got to get rid of that exponent, so we're going to take the 4th root of both sides. So the 4th root of 16 is going to be positive or negative 2, because it's even, so we're going to have both of them. Then we're going to subtract 5 from both sides. Well, first we need to split it up. X plus 5 equals 2, x plus 5 equals negative 2. And then we're going to subtract 5 from both sides, so 2 minus 5 is negative 3, or negative 2 minus 5, which is negative 7. So that's where those 2 answers came from. Alright, next one we have, right, there it is. So again, the exponent is odd, so we have one solution. And the exponent is on the outside of the parentheses, so we're going to get rid of the exponent first. So we take the cube root of both sides, and we have x minus 2 equals the cube root of negative 14. Negative 14, again, doesn't have a nice, pretty cube root like all of these. Will come out nice and neat. This one's not going to, so we're going to leave it like it is for right now. And it's just the cube root of negative 14, not positive or negative, because 3 is odd, so it's just one solution. So next we get rid of that minus 2, so we add 2 to both sides. And we have x equals the cube root of negative 14 plus 2. And we can take this, stick this in a calculator, and we get approximately negative 0.41. So number 17. And here we're going to have to flip back to that other slide, because what it wants to do is take in example 5, the last one we did with the hospital, what would the percentage rate be if the salvage value was 6,000 instead of 8,000? So all we're going to do is we're going to come back here, take a look at this. So our salvage value is going to change. It's not going to be 8,000 like it was before. It's going to be 6,000. But it still costs us 50,000. It's still going to last us 10 years. So what we have here, we're going to plug in 6,000 there instead of 8,000. We can simplify that. That's 3/25. And then we'll just take this, stick this in your calculator, and you get approximately 0.191. And then we're going to need to change this to a parenthesis, to a percent. So you just move your decimal over 2, and you get 19.1% approximately. And so that is rational exponents in equations and what we do with those. Hopefully that wasn't too bad. I hope this helped, and I will see you next time.